So the purpose of this video is to help you with our Applied Learning 2A assignment, specifically looking at this first chart, figuring out the number of valence electrons and figuring out the number of electrons to gain or lose to reach the lowest energy state. So I'll do my best to try to see if I can talk us through this. All of this comes from what we refer to as the octet rule. So we're really doing kind of an applied learning assignment using the octet rule. And the octet rule states that for the first electron shell to be considered stable, it needs to have in it 2 electrons. The remaining shell, remaining shells to be stable, and with relevance to this assignment, it's going to be the second and third shells to be considered stable. They need to contain 8 electrons. So atoms that do not have filled outermost shells are not stable, and they will attempt to form bonds with surrounding atoms in order to satisfy this octet rule, in order to try to create a stable outermost shell. The outermost shell is referred to as the valence shell, and the electrons within it we refer to as the valence electrons. So let's take a look at the first one here. We're given the example of hydrogen, and the first thing we need to look at is the atomic number. Hydrogen has an atomic number of 1, and what the atomic number tells us is the number of protons found in the nucleus. So if hydrogen has an atomic number of 1, that means it has, I'm just going to change color here, it has 1 proton in its nucleus. Now, for hydrogen to be uncharged, that proton has got a positive charge associated with it. So for a hydrogen atom to be uncharged, it is going to be orbited by a single electron, by 1 electron. And we're going to put that right here. So in this situation, hydrogen is uncharged, but it is not stable. It is not satisfying the octet rule. If you look here, we are in our first electron shell. That first electron shell to be stable needs 2 electrons. It's only got 1. So it has basically 1 empty binding spot. So we can fill in our table here. Our number of valence electrons, there's only 1 of them, but it wants to have 2 in order to be stable. So in order to reach that point of stability, it either needs to gain a second electron, or it could also lose the first one. So the correct answer here is actually to gain or lose 1 electron. Okay, let's take a look at, let's see, let's do nitrogen. So let me just erase a little bit here and grab another color. And let's take a look at nitrogen. So again, it tells us our atomic number. The atomic number is the number of protons. So we have 7 protons in the nucleus, and there's going to be neutrons as well, but we can disregard them for the purpose of this exercise because they do not have a charge associated with them. So we'll take a look at nitrogen with its 7 protons. So in order to be uncharged, that means it must also have 7 electrons. So let's see where those 7 electrons go. The first 2 electrons can go into the first shell, as stated by our octet rule. The remaining 5, however, can't fit in this shell. They have to go into the next shell. So in our second shell, we will have the remaining 5, 2, 3, 4, 5. So now we have 7 protons surrounded by 7 electrons. That is what our nitrogen atom will look like. So it is uncharged, but it is not stable because it has not satisfied the octet rule. In order to satisfy the octet rule, this second shell wants to have 8 electrons. It's only got 5. So that means that there are 3 empty bonding spots. So nitrogen will want to react with atoms around it in order to fill those spots and to satisfy the octet rule. So we can now fill in our number of valence electrons. We can just count them: 1, 2, 3, 4, 5. Okay, but it's not stable. It wants to gain another 3 in order to satisfy the octet rule. Now, common question, why not just lose 5? It could, but in chemistry, it's going to have the tendency to gain the 3 as opposed to losing the 5. So go with the lesser of the 2 numbers. Let's see what else we have. Let's do one more. Let's do sodium, to show you what another situation looks like. Let's just grab one final color. Let's go with purple, right? And let's take a look at sodium here. So here we have atomic number of 11. That tells us that there are going to be 11 protons. In order to be uncharged, we need to also have 11 electrons. According to the octet rule, the first 2 will go into the first shell. And then we have 11 to deal with. We've only used 2. We can start adding more into the next shell. And we can actually fit all 8 into the next shell. Let's get them in here. So now we have a total of 10 electrons, but we need one more to balance off these 11 protons. The next one will actually go into another shell, the next shell out. Okay, so this now is what sodium looks like, and sodium is uncharged at this point, but it is not stable. It has only 1 electron in its outermost shell. It wants to have 8. It actually has 7 empty binding spots here. However, it is far easier for it to lose 1 electron than to gain another 7. So the number of valence electrons is going to be 1, and it's going to want to lose that 1 electron in order to be stable. So I hope this is helpful. Feel welcome to reach out again if you have any questions. My best advice is to give a shot at this table and see if you can work it out. Know that if you get them wrong, you will have the opportunity to correct and resubmit based on my comments. So give it a shot.